Assalamu alaikum. Welcome to the CSITEd Experts Data Science A to Z Bootcamp. I am very much excited that at this point we have reached in a good situation that I have discussed how to develop a simple linear regression model using uh, a simple data set as well as using a comprehensive data set. So I discussed in the previous last three videos, I discussed how to create a simple linear regression model using sklearn library and using self calculated regressor. Especially in the last video, I discussed how to develop a simple linear regression model using for a comprehensive data set for any kind of data set. Actually we can use our self calculated regressor in order to uh, find out a predicted value. So this program I discussed already. So in this video I want to discuss, I want to go through something more. For instance, I want to discuss how to develop a simple linear regression model for any data set, that means any kind of data set in Python using self calculated regressor. So I believe this will be an extension of the previous tutorial. So this is very simple, as it is already discussed in the previous tutorial. So here I have my comprehensive salary data is CSV. Actually, let me clean everything. So let me import my libraries, and then let me import my data set. And this is the data set that it has 50 rows and 8 columns with these are the experience, education, performance, dedication, language, gender, ethnicity of these are the maybe let us consider that these are the independent variable. These sevens are independent column set of a company, of an imaginary dummy company's employee information. So let us think that, okay, let us avoid any kind of biasness. Okay, so although gender and ethnicity have no effect on performance or salary, but maybe there might be some companies they may consider this. So but in the our purpose is to learn actually how to handle with any kind of data or a large data set. So gender over here is encoded with 0 and 1, maybe for 1 for male or 2 for female, or sorry, 0 for female, 1 for male, or 0 for female, or vice versa. And maybe the ethnicity is data is based on 5 scale, 1 to 5, with maybe 1 for Asian, 2 for American, 3 for something like this, European or something. And so the experience over here is very simple. There is straightforward that it is years, measured in years, and total total years of education, whether an employee has studied 10 years or 12 years or 16 years or 5 years during his lifetime. And the performance is measured based on a 5 scale, and the dedication to the company may be measured on a 10 scale, and language, how many languages an employee knows. So for instance, these are the independent variables columns, and finally the salary column. Okay, so at the end of our last video, so I discussed that by using this model, by using self-calculated regressor, we can work for any kind of data set. For instance, here I will show you here. Okay, so I have my comprehensive data set over here with, let me show you my comprehensive data salary set with seven columns of independent variables, 1 2 3 4 5 6 7, and 1 columns of dependent variable. But if I want, I can only take only 1 column. So here if I take 0 to 1, 0 is the first column index and 1 is excluded over here, so 0 to 1 will get only first column index over here, only 1 column. You see that I got only 1 column over here. So this is the one I can take, this is as 1 column. Okay, and this is my y is column 7th, only 7th here because 8 is excluded, 8 is not included here. Okay, so if I run this, then I got my y as one column, and in this case if I want to print x and y, then I will get x in 1 column and y in 1 column. So then I can find transpose of x, I can find transpose of x transpose multiplied by x, I can get this. I can get x transpose x in whole inverse, this one. These are the steps of my beta calculation that you should be familiar so far. And this is my regressor. So once I get my values of x, I can print x, and actually I can print regressor at this point. This is my regressor. Since I have only 1 columns in my independent variable, so I can take a regressor. If my regressor will have only one value. Okay, so then if my x features has only with 1, you see that how I have to write, I have to enclose this 4 within 1, that means 4 is here is 1 row 1 column, only single element in a matrix that has only 1 row and 1 column, that means this value. But I have to enclose this within another square bracket, and the whole thing I have to enclose within another square bracket. So this is my feature value, that means my experience is only 4 here. Then my predicted value will be compared with, so matrix x feature times my regression matrix. Okay, so this is my y predicted is calculated nicely because there is no error. Now if I want to print my x feature and y predicted, then I got this. Okay, then similarly for 6-year experience, I will get this predicted salary, and for 8-year experience I will get this predicted salary. Now I like you to compare so these values. Okay, compare these values with the program that I discussed with using this one has only 1 column with the only experience salary. So if you do practice, then you will get same result, exactly same result, You see that. Let me let me get these values, get this, let me get this name. Let me copy this, and if I run this correctly in this model, actually I need this, and I need regressor, and I need this. So now let me compare side by side with these values. Okay, here these are my actually the new calculated. So I'm working with the for this one, my current program, and this was my previous result. Let me compare this. I want to compare this. You see that my regressor is previous regressor was 13230, and this is now exactly same. And for 4 years experience, previously I had 52920, and now I have 52920. And for 6 years and 8 years experience, the predicted salaries are exactly same. Okay, so that means I can use this model for any kind of data set. Okay, so for instance, let me give you I want to give you a homework, that your home task, that I like you to play with this comprehensive salary data, and sometime take, like for this one, for instance, 0 years of experience and 10 years of education, how much will be your predicted salary for an employee. So let us do that. How do we do that? So here, so far I have only one column taken in consideration as my independent variable, but I want to take in consideration in two columns, both this column and this column. How do you add that one? So I need to add exactly 2 over here, right? So then I will get 2 excluded, but I will get 0 and 1. That means I will get let me clear everything so that you understand that these are newly generated. Okay, so let me get this. My data set is here. So if I say x is like this, then I will get x in 2 columns, right? This is my experience column, and this is my year of education column. So then my y value will be exactly same, because my y value will be exactly same because I have only one column of dependent variables. So then I can use same formula for calculating my regressor. But here, so you see that my regressor has one column and two rows over here. This is a regressor, actually vector. Okay, so why did I get two rows over here, two regressor value over here? Because remember that we had 2 columns in our independent data set, so we will get 2 values in our regressor. Okay, that's it, otherwise it will not work. And now my feature, for my feature, I will provide what? I will provide I will provide two values over here, one for experience and another for education. So let me get something 4 and 15, maybe 4 and 15. So let me run this one. So with 4 years of experience and 15 years of education, I got my predicted salary, annual salary is 66,000, right? So it's correct. So if I do have 4.4 over here, then 4.4 over here, and 15. Okay, so let me try to run this. So with 4.4 and 15, 4.4 years of experience and 15 years of education, then I got 70,000. And previously, let us compare this one with 4 years and 15, then I got 66. Okay, it's better, it's increased right now. So let me compare this with okay, so let us go, let us do a few more. For instance, 615, 615 and 815. Now let me execute all of these and let us run this. So let me make it 4. I want to compare these values with my previous values. So you see that this one, I have this, and let me make it side by side. Make it side by side. And you remember that in my from my previous video, I have copied of my previous values with a simple data set with only 4 years of experience. I had 52,000 my salary, predicted salary for yearly, but with 4 years of experience and with 15 years of education, I got 66,000. That means my education column has an effect over here, right? So similarly for 6 years, only 6 years, I got 79 here, and for here with 6 years and 6 years of experience and 15 years of education, I got 85 years with 85,000 predicted salary. And for 8 years of experience and 15 years of study, I got 104, and previously I had 105. So that means my education column has an effect in this model, right? Okay, so now if I like you to play with this model and play with this, then I believe you will understand. So now try to consider, okay, add more columns, like you can add experience, education, performance, dedication. So you can add 4 columns over here, 0 to 4. That means you will get 4 columns, 0, 1, 2 and 3. And then you will have your dependent same, but what you need to change over here, think about a second. By the time I rerun my x, you see my x is now has 4 columns. Only the thing that you have to change over here, that your feature x will be with 4 values, like with 4 and 5, maybe with something 4 and 5, and maybe something like this. So then once you do this, then you see that my previous regressor have 4 values, 4 independent values, because for each column of the independent data set. So now if I'm good, if I run this, I will get my predicted salary for this combination of data. So now I like you to play with this data set, and I believe once you make some changes in your program and try to run it, and then you will have a good understanding of how to use this model for developing a simple linear regression model for any kind of data. And by the way, that uh, in the previous video I discussed that it is not possible, that there is a limitation of this model, that it is not possible for us to visualize this visualize this regressor line. Okay, because the reason is that here you remember that here my dependent variable independent variable data set has 4 columns. That means it is 4-dimensional matrix, so, or a vector, or 4-dimensional vector. We cannot display 4-dimensional thing on a 2-dimensional plane, so it is not possible to this. And also I have a dummy Titanic data that is more similar with my comprehensive salary data. Okay, the Titanic data set has 8 columns as well as, so this will be pretty similar to this program. So I like you to do some practice and play with this Titanic data. So here the ticket fare will be the only dependent column, and all of these one and this 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 one will be in your independent data set. So I believe when you practice with this data set, you will have a good understanding of how to develop a simple linear regression model for any kind of data set in Python using our self calculated regressor. If you remember that in one of my previous videos tutorials, I discussed that this is our model for this one. So once you understand this this model, then you will be able to work with a comprehensive data set. For instance, in real life we use in healthcare data that has a person glucose level is considered both by its height, by its height, weight, age, gender, and with many uh, consideration, that how many hours he does exercise, what kind of food he eats. So once you understand this, then it will be easy for you to develop any kind of linear regression model for any kind of data set. Thank you so much. Thank you for watching this video. And I believe at this point, if you start watching these tutorials from beginning to end, then you will have a just start of learning data science. Actually, data science is a comprehensive and very large topic, so we just started our journey. We have not covered 10% of data science stuffs yet, so but we have a good startup so far. Thank you so much. Thank you for watching this video. Bye bye. Assalamu alaikum.